crash test dummies take all the hits, so that we don't have to. Today they're jam-packed with technology and can cost more than $1 million each. But despite decades of innovation, one thing has remained the same. The body shapes of the dummies themselves are still based on an average-sized man from the middle of last century. We went inside the factory of one of the top manufacturers to see how they're assembling the most advanced and diverse generation of dummies ever, and to find out why they are so expensive. Humanetics is the largest manufacturer of crash test dummies in the world, based, fittingly, just outside America's Motor City, Detroit. But ATDs, as they are known, are a rare breed.
People think that there's hundreds of thousands or millions of crash test dummies in the world. In fact, there really isn't. The entire world market probably sells about 300 crash test dummies in any 1 year.
The most advanced Thor design takes up to 5 months to complete. That's because they can include more than 30,000 parts.
It may look like a simple mannequin, but inside the dummy is a lot of engineering and a lot of time and a lot of work.
A complex combination of metals, rubber, foam, vinyl and plastics make up each dummy. And then inside comes an intricate network of sensors and electronics, which feed thousands of bits of data back to car builders about the kinds of force experienced in a crash. Here a worker pours the vinyl mixture into a face mould before putting it into an oven. And the finished product has got to be perfect. Each dummy needs to survive countless impacts while continuing to relay reliable data. Since the 1960s, car safety improvements, designed in part from data provided by crash test dummies, have saved an estimated 600,000 lives in the US.
So it has to be reliable not only for 1 or 2 crashes, but for tens of thousands of crashes over a lifespan that could be 30 plus years.
After moulding, each one is trimmed and finished by hand. Underneath the skin, a skeleton provides strength and durability. But unlike human bones, these ones don't break so easily.
Most of the bone structures are made out of steel and it has to be machined. We use numerically controlled machining to make sure they're precisely manufactured.
So inside here he's actually machining what is a hybrid 390 fifth pelvis. We have a print where we have to meet all the tight tolerances. He's machining out the hip sockets where the femurs are going to go.
Skulls, ribs and pelvises are all modelled after their human counterparts. Older models are crude compared to the latest high-tech generation. This Thor dummy even has a pelvis with movable parts.
The Thor pelvis is much more anatomically correct. It allows for more load cells and sensors to be installed on the dummy so that we can record more accurate information.
An array of sensors is used to detect which body parts would have been damaged or broken in a crash and which would have just been left with bumps and bruises.
Every injury that we are able to calculate is because we have literally sensors in every body part that's likely to have an injury. So it's very complex.
The sensors are built and calibrated in their own special lab. The newest dummies contain hundreds of them. When a dummy crashes, the forces come from different directions at different strengths. Sensors can measure compression, torque, impact, displacement and acceleration. Older dummies had cables running into them that sent information to an outside computer.
The weight of the cabling would bias the test in itself. So we developed a data acquisition system. This is really like the black box that goes inside the crash test dummy. But what that does is captures the data in microseconds from the crash, and then that can be downloaded separately.
It's no wonder that a dummy comes with such a hefty price tag.
And if you look at our most advanced crash test dummies with hundreds of sensors and 30,000 parts, hand-built to the most biofidelic standards in the world, they can be as much as $1 million.
Yet the majority of crash tests are still carried out with less sophisticated dummies.
The vehicle is underway.
And in spite of the fact that more women than men in the US hold driver's licenses, ratings agencies continue to use dummies based on a male body shape to compile their star ratings for car manufacturers.
For front crashes, we use a hybrid 3 dummy that represents a mid-sized male. For our side crashes, we use what's called a SID2S dummy, represents a smaller female occupant or an adolescent.
Women and adolescents are represented by smaller versions of the male body shape. Even the male dummies used in tests are behind the times. They're modelled on the height and weight of a man in the US from the 1980s. While height hasn't changed, waistlines have. The average man has put on 20 pounds since then, while the standard dummy has not. Humanetics and other dummy manufacturers began designing more representative dummies more than a decade ago.
The abdomen is slightly more biofidelic than the 50th has historically been.
The Thor generation of models include both a male version, the Thor 50th, and a female version, the Thor 5th.
The difference here is it's not a scaled-down male. This is truly a female crash test dummy. And if you look at the Thor 5th, there are many new sensors that have been added to specifically address the injuries and concerns that we're seeing in the field associated with female drivers.
Better reflecting real body shapes and sizes means a wider variety of dummies and greater production costs. But the net result is better data and safer vehicles.
You can actually provide additional information back to the designers of the car companies, the designers of the airbag, the seatbelt, and the other restraint suppliers, and they can use that information to build even safer cars.
However, the cars that we'll see years from now might not ever be tested with crash test dummies at all.
The future holds potentially many changes for our industry. One of the things that might change is that we will be conducting less physical testing with real dummies and real vehicles, and more testing in the virtual world to represent a wider range of speeds, impact angles, a wider range of occupants, male, female, different sizes.
For now though, crash test dummies are still painstakingly pieced together by hand, and they're our best chance of surviving a crash, even if the cars they ride in all end up the same way.